What I have on the board is the current procedure for solving equations. A more efficient procedure for more complicated equations will come when the more complicated equations come in probably the next couple lessons. What we're doing here is we're trying to solve equations. And first step is to combine like terms on each side according to this process. I'm going to add a step 0 in here, which is not a required step but a recommended step, is to get rid of fractions. Okay, the same way we got rid of fractions on Monday, lesson 25, we multiply every term by the common denominator, fractions go away. Alright, once you get rid of fractions, combining like terms is a matter of adding or subtracting based on sign. If they both contain the letter x, they're like terms. If they're both just regular numbers, they're like terms. Once you've done this step, you're going to have at most a variable number. Alright? So 5x plus 7 equals 2x minus 3, something like that. Alright? Move variable to one side, constant term to the other side. Moving on an equation, the easy way to do this is to change signs when you move across the equal sign. So if it's negative 7 is here and the equals is here, move it over, it becomes a positive 7 over there. If a 5x is over here and you move it across the equal sign, it becomes negative 5x. Alright, so whatever sign it is, it changes. Okay, that'll create two x terms on one side, two numbers on the other side, combine like terms again, and then divide by the coefficient. Whatever number's in front of x at that point, divide by it and get the answer. And one thing that happens here in this class, Algebra 1 with students, is sometimes people get hung up on, I'm not sure which side I'm supposed to move things to. I've heard people specifically tell me this. I kind of understand equations, but I'm not sure exactly which side I'm supposed to move the variable onto. Example 1 and 2 deals with that exact topic. If you notice, examples 1 and 2 are exactly the same problem. That's on purpose. Okay? For 26.1, I'm going to have the variable on the left-hand side, 26.2 variable on the right-hand side. Okay, so making that decision of move variable to one side, move number to the other. On this one, I'm going to move variables to the left-hand side. So, notice 3x minus 4 equals 5x plus 7. Are there any fractions?
No.
So skip the fraction step. Okay. Looking at the left-hand side, 3x minus 4, are those like terms?
No.
Are 5x and 7 like terms? No. So skip the like terms step. Okay, it's a process that's there. If nothing's happening along those lines, move on to the next step. Step 2 says move the variable to one side and number on the other. Here I said variable on the left. Okay, so 3x is on the left, it's where it belongs. I want 5x to go over there with it. So here's how you move something. You take what you'd want to move across the equal sign and let it happen. Okay, so I want 5x to be over there. Go ahead. The consequence of moving it, though, is that it changes sign. So move the 5x over to the left. It's positive 5x to the right, moves to the left, becomes negative 5x. Don't worry about the fact that this makes negative 2x. We'll do that in a moment. All right? Also within step 2, if I move the variable to the left-hand side, that means I want numbers on the right-hand side. 7 is right where it belongs, 4 isn't. So 4 belongs over here. What kind of 4 is this? Negative. So it moves across the equal, comes? Positive. Okay, strike it out where it's at, put it where you want it to be, and change its sign. Each thing I did there, notice it moved across the equal sign. Only if you move things across the equal sign do you do this. If you're on the same side of the equal sign, they're like terms, combine them. That's step 1. Okay, but if they're on different sides of the equal sign, that's when you move them and change the sign. Now, at this point, I'm going to add or subtract based on sign. These are opposites, so I subtract. 5 is bigger than 3, so it's negative. Notice the x stayed there. Okay, don't let x's disappear. Don't let variables disappear in your work. 7 and 4 are the same sign, so I add. 7 is bigger, so it's positive. Negative 2x equals 11. Step 4, divide by the coefficient. Wherever x is, or letter, whatever the letter is, wherever that is, the number in front of that's the coefficient. So I'm going to divide by negative 2 on both sides. That gets me my answer is x is equal to negative 11 halves. Alright? I'm going to slide over to example 2 real quick, then I'm going to show them both side by side. Example 2, exact same problem. The answer should be the exact same answer, but this time I want the variable on the right-hand side. Same scenario as the last one. We have 3x minus 4 and 5x plus 7. Once again, there's no fractions, there's no like terms, so there's no way to simplify it any. It's ready to go at this moment in time. If I want the variable to be on the right-hand side, that means 5x is where it belongs. 3x needs to move. So 3x needs to move. Strike it out, put a negative 3x here. And moving it across the equal sign changes the sign. 7 needs to move. It's positive 7 here. It's moving across the equal sign. It's become minus 7. Once I get to this point, notice negative 4 and negative 7 have the same sign, so I add 7 is bigger, so it's negative. 5x and 3x have different signs, so I subtract. 5 is bigger, so it's positive. At this point, 2 times x, once again, x is my variable, which means 2 is my coefficient. I divide both sides by 2. That gets me x equals negative 11 halves. Okay? Now, if we look at them side by side, 11 over negative 2, negative 11 over positive 2, they mean the same thing. Where the minus sign occurs is not relevant, but you get the same answer. So that's step 2 where it says move the variable to one side, move the constant to the other side. It doesn't matter what the one side and the other side are as long as they're on opposite sides. So here's my equal sign, x on one side, number on the other. Here's my equal sign, x on one side, number on the other. So as long as that happens, you're in good shape.